So yesterday we took some introduction on Azure Data Engineer products. You can say services or products. And we did a discussion about Azure SQL. Then Azure Data Lake. Then we talked about Azure Synapse. Actually, full name of the service is Azure Synapse Analytics. And finally, your product is Azure Data Factory. Still, you have other products. We are going to discuss about remaining products 5, 6, 7, 8. So before stepping into them, just a quick review of the previous. What is Azure SQL, sir? Is a cloud RDBMS database in Azure that we used for loyalty. Okay, you cannot use Azure SQL for the data warehousing or analytics services. For end user transactions, you can use loyalty. And I need a warehouse, data warehouse in the RDBMS, that too in the cloud. For that, I have Azure Synapse Analytics. Actually, Azure Synapse Analytics is a package of services. Different Azure services. These packages, the package includes Azure Data Lake Gen 2. If I take Synapse Analytics, no need to separately take Azure Data Lake Gen 2 version. Automatically, whenever I install it, that means whenever I create resource of Synapse Analytics, first the Gen 2 storage account will be available to me. And there is second thing, I have Azure Synapse SQL Pool DB. The short name for this, Synapse DB. This is your cloud data warehouse. This category also, the category of the database, RDBMS database. And also one more thing you have here, Azure Spark Pool. Okay, it gives you Spark cluster, and you can run Spark jobs to process big data. Okay, so mainly here, Synapse SQL Pool DB, simply you can call it as Synapse DB. This is a cloud data warehouse. Category RDBMS. About this Spark and everything later we will discuss. If I am a user, if I perform a transaction, my transaction is recorded into OLTP systems. But how to bring that OLTP systems data into this data lake or Synapse DB? By using Azure Data Factory. So simply in rough terminology, what is Azure Data Factory means your comment is a cloud ETL in Azure platform. But in fact, your work style is not ETL, your work style is ELT. What is the difference between ETL and ELT? Remember, sir, here, Azure Data Factory support both operations. It will support ETL, it will support ELT also. Okay. ETL full form is what? Extract, transform, and load. This is reverse. First step extract, load, and then transform. Okay. So when to use what kind of technique? Your ADF supports both operations. Understood? This ETL is suitable for small volumes of data. Generally, if the data is in GBs, you can use it. But if data volume is in terabytes or multi-terabytes, the ETL style is very bad. because processings will take even a day's time also, some big processes. That's why here we go with the ELT style. For this is suitable for big volumes of data. Maybe TBs or multi terabytes, even hundreds of terabytes, whatever it may be. Okay. So for big volumes of data, ELT style is required. So about these 4 products in yesterday class we have discussed. Okay. Of course, even though you are a ADF developer, but you will have to interact with all other products. That's why you should get idea about them. Still, other data engineer products like Azure Databricks and Azure Cosmos DB, Azure Streaming, and Azure Key. These are other important products. So what exactly these 2 things? Step by step we'll see. I'm going to talk about Azure Databricks. Sir, Azure Databricks is a Spark cluster. That means the Databricks provides you Spark cluster in Azure platform. So independently, what is a Databricks? We will see first. Databricks, if you talk about Databricks, simply Databricks provides Spark cluster in cloud. No need to come to Azure Databricks. Directly databricks.com you can open and you can set up your cluster. So one thing, first of all, what is a Spark first? The Spark is an execution engine. Process big data with high speed. Got it. The Spark has 2 key features. Number 1, in-memory computing feature. The in-memory computing kind of model is very faster. This is 100 times faster than regular disk computing models. Okay. This is reason number 1. Second one, it supports MPP. MPP means massive parallel process. Because of these 2 features, your data processing is very fast. Sir, actually, yahoo.com in 2016, they tested with Spark with 390 nodes. The test was about 1 terabyte sorts. This is done in 1.2 minutes. Spark has a cluster. The cluster has 390 nodes. With that 390 nodes, 1 terabyte sort happened in 1.2 minutes. Good speed or bad speed? Very, very great speed, sir. Because same test in 2013, the test was done with Oracle database. Because at that moment, Spark not yet released. Oracle has done 1 TB sort in 3.5 days. It seems very bad speed, but in fact, in those days, Oracle recorded good mark when compared with other regular databases. SQL Server kind of databases took 6 days time. MySQL, during the process only system hanged out. Got it. After that, they tested with the Teradata. Teradata has done the same operation in 4.5 hours. Again, Netezza, 2 hours 50 minutes. That means internal architecture of Netezza is different when compared with the Teradata. Here in the case of Oracle, there is no parallel processor on that moment. No parallel process. But here in Teradata, there is parallel process. Netezza is supporting, again, parallel process. Just because of parallel process, the speed increased. After that, Hadoop kind of systems came to the market in 2011 only. But test was done in 2013. Hadoop has done 1 terabyte sort with the 390 nodes in 4 minutes. At that moment, the execution model is MapReduce, not Spark. Backend execution model is MapReduce. After that, Spark came into the picture. The Spark on the Hadoop. For storage of the data, they are using Hadoop. For processing, they are using Spark. It has processed in 1.2 minutes. Now you just compare where is 1.2 minute and where is 4.5 hours, and where is 3.5 days. So which is the high speed processing system, especially for the big data, is that is Spark. That is what simply Spark. Why Spark is speeder means these are the two reasons. In-memory computing. Second one, massive parallel process available in other systems also, like Teradata, Netezza, Hadoop. In those systems also parallel process available. So majorly parallel process with in-memory computing. Okay, that's why this is super speed execution system. But the problem with the Spark is the Spark problem. Independent, it cannot run. Always it needs a cluster. Cluster means what? Yesterday we discussed about cluster. A group of network of nodes are acting as a server. A group of network of nodes are acting as a server. It needs a cluster. Without cluster, it cannot run. It cannot execute the processing. Understand? So Spark runs on on-premise clusters like Hadoop. Even if it is cloud, in the olden days it was available only for AWS. Nowadays available for all other clouds also. Got it? Okay, sir. I'm going to talk about Spark on-premise cluster. With Hadoop. In Hadoop, we have 500 nodes. Okay. One master, 500 worker nodes. And you install the Spark on it. Now think that this 500 node cluster is worthy for 2 terabyte of data processing at a time. Suddenly tomorrow your data volume increased. Again, what you have to do? If your process executed by same existed 500 node cluster, the process slow down. Understand? Because data volumes more increased. At the time you need to scale up. Scale up the capacity of your cluster. How you can scale up? By adding few more nodes. By adding few more nodes, maybe 100 nodes you are adding. Again, after that, after 1 month, you are adding some 200 nodes like this. Every time scaling up your physical data center is very tough for you. Because in the olden days, on average, yearly 5 terabyte, 10 terabyte, on that way data volumes are increasing. But nowadays, day to day, multi terabytes of data volumes are increasing. That's why everyday scaling up the data center is very tough for the organizations. Understood? That's why they need cloud. That way they means here industry needs cloud clusters for Spark. I need a same cluster in the cloud, that too with auto scaling capability. That means every time I need not to add the nodes, automatically nodes should be engaged based on my data workloads. Got it? That's why there needs a cloud cluster with auto scaling for Spark. So who is providing that cloud cluster with auto scaling? That is by Databricks. Okay. So simply what is a Databricks means your regular general answer based on this is a cloud Spark cluster. Is a cloud Spark cluster with auto scaling. Today, as per my data load, only 100 nodes are enough. Tomorrow, data volume increased. Automatically, that should be extended to some 200 nodes. Again, processing is completed. Again, it should revert back to my 100 node. Understand the points in this way. So that is what the meaning of cloud Spark cluster with auto scale. This is simply a Databricks. Clear? But this is general Databricks. It cannot interact with my Azure data storage services. In my Azure, what are the different weapons to store the data? Can I store data into Azure SQL? You can. End user transactions can be stored into Azure SQL. And data lake, all my structured data, unstructured data, semi-structured data, I can keep into data lake. And I have a warehouse environment, which is Synapse DB. Understood. Of course, ADF is not a storage, it's just a data integration service or data ingestion service. Can extract data from one source and can write it to other target. It's not a storage weapon. Still, I have Cosmos DB, which is NoSQL database. All these are the different storage services, but this regular Databricks is not compatible with all my Azure data services. That's why Microsoft and Databricks did some work collaboratively, and they launched a new product called Azure Databricks. Understand? So this Databricks simply, what is Azure Databricks means? Same thing is a Spark cluster. The Azure Databricks is a Spark cluster on Azure Cloud. Then what is the difference between Databricks and Azure Databricks? This Databricks is not compatible with my Azure storage services, but this Azure Databricks is compatible with all my Azure storage services. Understood the points? Now I have a data lake. I need to read the data from the data lake. My Azure Databricks can read simply. If it is normal Databricks, you need to do a lot of other settings. You need to call different types of APIs. But if it is Azure Databricks, simply how you are reading data from normal file, that was simple. It can read data from my data lake. Same thing from my Cosmos DB, from my SQL, or from my Synapse, whatever it may be. Understood the points? So simply the comment about Azure Databricks is a Spark cluster with auto scaling and compatible to all Azure Data Storage Services on Azure Cloud Platform. This comment you can do. This is not definition. This is just a comment, a statement. Got it? Got the difference between a normal Databricks and Azure Databricks. Got it? Remember, sir, Databricks not only available for Azure, Databricks available for AWS also. Databricks available for Google also. Understand? AWS people are using AWS Databricks. In Google, you have Google Databricks. On that way, in future, Databricks is going to be common product for all the cloud platforms to process the data. Understand? Finally, in Databricks, who is processing your data? Finally, in Databricks, who will process the data? Spark will process the data. Then what Databricks is doing help to you? I like Spark. To execute that Spark, I need cluster. That too, the cluster should be with auto scaling. That too, my cluster should be compatible with my Azure Data Storage Services. That those three features are provisioned by this Azure Databricks too. Clear, all of you? Okay. Suppose if it is Databricks, let's say Azure Databricks. Your Spark is the execution weapon. But you are a developer to give instructions to process the data. In the form of coding, you need to give those instructions to perform your complex transformations like that. The Spark coding will be done by, that means Spark code can be done with following languages. Number one, Scala, because the Spark is developed with the Scala language. Number two, Java. Number three, R language. And number four, Python. Maybe in future other languages also. But most of the things, especially in Azure platform. Of course, sir, Azure Databricks doesn't support this Java, remember. In normal Databricks that is available, but not in Azure Databricks. Okay, so you can write in Scala, you can write in R language, and also you can write in Python. This Python plus a Spark is called PySpark. Most of Azure Data Engineer, in the Databricks applications, PySpark is the majority of the code. Okay, it is not the rule. Currently, most of projects are available in the PySpark, especially for Databricks side. I am a ADF developer. You are a Databricks developer. Definitely, you are weak in ADF areas. If I am ADF developer, definitely I will be weak in Spark kind of coding or PySpark kind of coding areas. That's why currently industry is taking two separate people. Databricks, separate developer, ADF, separate developer. But in future, this situation may not be like this. They are expecting multi-skill from you. Initially, you can step in as ADF engineer, but slowly you should adapt the skill set of Databricks also. Okay. Yeah. So simply, what is the advantage of Databricks? You just give a small comment. What is a Databricks? I'm not asking about Azure Databricks. Asking you, what is Databricks? Databricks is a provisional of Spark cluster with